Hi, welcome to the Dummy Programmer. So today we are going to solve a question called repeated DNA sequences on Leetcode. It's a medium level problem. And what it says is that given a DNA sequence is just a string composed of 4 unique characters, A, C, G, and T. It wants us to look for 10 letter long sequences or substrings that occur more than once in the input string. Okay. I paraphrase because the question is too long. So, for example, if this is your input string, in this string, we have to look for all such substrings which are 10 letter long, which occur more than once in the input string, right? So, for example, if this is a substring of 10 characters, we have to check in the rest of the string whether this exists or not. And you can see it here, it exists here, right? So then we have this also, and this also exists, right? So we have to put all such substrings in an array and return that array as a result. Okay. So how are we going to solve this? If we go about it in a brute force approach, what we can do is we can basically find out all possible substrings of the string and put it in a data structure, and then basically while putting in the data structure we check whether it already exists there or not, and if it exists, then we put it in a result array and return it. That's what basically we are going to do. Okay, but we are going to do it in a slightly better way. I won't say, it's a drastic difference, but it is still ON. Okay. So let's say this approach is called sliding window approach. You'll see it a lot in a lot of problems. It's a very famous approach. So what we do is we create a window of, in this case, 10 characters. Okay, and we start iterating from the beginning of the array, the front of the array, and we create a window of 10 characters. Okay. So let's see. So this 1, 2, 3. This is what, 4, right? 5, 6, 7, 8, 9, 10. Okay, this is a window of 10 characters. Now, if we have a data structure, pick the data structure carefully as per your language. What we want is that the addition to that data structure and the contains to check whether a string exists there or not should all be O1 time, right? So in Swift, it is set. And set has additional properties, like it can only hold unique values, and that's why we are using set here. So we add this in the set. Okay, so we maintain in this case 2 sets. One set is of all possible substrings, basically. So let's say all substrings set, and then we have another set which is a result set. Okay, so every time every window that we are processing, first we will check whether this string already exists in this set or not. If it exists, we insert it into the result set also. Okay, and then we move the window forward 1 character. So if you move it forward 1 character, it is going to move like this, right? So this A has been removed and this A has been added to the window, and then we where is it? Yeah, this is your next substring, right? And then you check whether this exists in this set or not. If it doesn't exist, you add it here. Okay, and if it exists, we insert it into the result array. So right now nothing's there in the result array because we have not found a matching a duplicate substring yet, right? So a result is empty, all substrings has this value, and then we move this window forward 1 more time, and then this is your substring. Okay, so again you do this and you check whether this exists here or not. If it doesn't exist, you add it here, and then I think you get the point. Like, we move 1 character forward until we reach the end. Okay, what is the ending criteria? We have to reach 10 characters before the end of the array, right? Because the window has to have 10 characters. So your pointer has to point 10 characters before the end of the array. So this is where you reach. And by the time you reach here, you will have this this set, and you will have this set, and you convert this set into an array and return that as your result. So this is basically what we're going to do. You can read up more about sliding window. I think you'll find a lot of problems. It's a very popular approach. Let's code it out quickly. Okay, so how are we going to do this? I'll first convert this input string into an array, because random access is very helpful when you're trying to access characters by index, because accessing characters by index in Swift strings is very difficult. So I'll just convert this into a character array. Okay. Then let's calculate the length of this. This is array.count. Okay. We need all substrings set, which is going to be a string set. Okay. And then we have a result set. And then we return the result. Okay. Yes, one base case we have to first check, right? If s dot count is less than, if s dot count is less than 10, then we just return an empty array. So please make sure to cover base cases. I also forget to do that sometimes, but that's where your test cases are going to fail. 1 or 2 test cases will fail, and then you'll be rejected. So make sure to do that. And so now let's run a loop. Okay. X is equal to 0, x equal to x plus 1. What is the stopping condition? X has to reach 10 characters before the end of the array, right? Because we need a 10 character window. So x is going to be less than length minus 10 plus 1, because it's an index, right? So it's going to be basically 9. Okay. And now what do? It's actually pretty simple. Substring array will be equal to array x. Oh, no, it has to be this, right? X plus 10, because this x is inclusive, right? So 10 characters will be until here. And then is equal to what happened? Okay. Now we check if all substring dot contains this substring. If it already contains, that means it's a duplicate one, right? More than one occurrence is there. So we add dot insert the substring, else we just add it here. Insert substring. Okay. I think this is it. Okay, one more optimization here, okay, that you can apply. I'm not going to apply because it's a lot of work, but you can do that. Right now, these sets are basically supposed to contain strings, right? So we are going to hold strings in them. But actually, what we want to know is whether a substring already exists or not, right? You could also create a hash value of this, of each substring, and store it. Okay, because every character, a substring is more than one character, right? Every character will either take 2 to 4 character, 2 to 4 bytes, right? In Swift, it is going to take 2 to 4 bytes, right? If you create a hash value of each string, you could save some space, because you could convert it into an integer, and you could store it into a 32-bit integer, right? That is one optimization that you can use. But then also note that calculation of hash will also take some time time, right? You're saving on space, but you're spending some time on, you're increasing your time complexity. But again, it depends on what kind of hash you create. Okay, so you go through, you can try and go through the different ways to calculate hash in Swift, and which is the most optimal way to create the hash in Swift. But also note that creating hashes can also, then you can have hash collisions, right? You can have duplicate hash collisions, depends on the size of the input string. And there's one way which I think is going to be, in this case, because it has only 4 unique characters, right? So if you have 4 unique characters, you could do this. So let's say you represent it with 1, 2, 3, 4. Okay, then you can, there are only 4 possible values, so you can convert each substring into a 4 base number, right? Base 4 number, by representing it with 1, 2, 3, and 4. So in this case, for example, C is 2, right? So it could be this number, you can represent it with 2 into 4 raised to the power 0. And then based on the position, you can keep doing that, right? So in this case, again, this will be plus 1, and then again, you can do this. Okay, so you can look into this. This way also you can calculate the hash. But again, keep in mind that if you're going to create the hash, you're going to increase the time complexity, but you're going to save some space. So it's up to you whether you want to do that or not. I'm not going to do that. It's a lot of work. So I think this is the solution. Let's run it and see if it works, or if I, what did I do? Okay, I have to convert it into an array. We have to return an array. Let's see. Yes, it ran. 5 milliseconds, it's okay, not too bad. I think this is the solution that I have for you for today. Thank you for watching. If you like the video, please like it, share with your friends, subscribe to the channel, and see you in the next video. Bye-bye.